Good morning, students. So in our last class, we discussed about some questions from the chapter integration. With the help of substitution method, we solved some questions from the exercise 7.2. So today we will do some more questions from this exercise. So some important questions we have to do, and from here the important question, if you see the question number 32, this one is very important question. So question number 32, and the question is given integration 1 by 1 plus of, this one is cot of x dx. So this one is the question, 1 by 1 plus of cot x dx. So this one is the question here. If you see the question is this one. Now here let's see how can we solve this question. So first of all, 1 by 1 plus of cot x dx, isn't it? So 1 by 1 plus of cot x dx means here with the help of substitution we have to solve. For this you see only one trigonometric function is here, which one is cot x. So first of all, what you have to do, if we directly substitute cot x, ddx of cot x is what? Minus cos x square x. So minus cos x square x is not present here. So that's why direct substitution is not possible here. In case of trigonometric function, so sometimes we have to arrange the question properly. So now here cot x means in place of this cot x, what we can write. So that's why when we have to start the solution, so we have to write here let I equals to integration of, this one we have to write 1. So this one is 1 by 1 plus of cot x. Cot x means we can write here cos x by sin x, isn't it, into dx. So cot x means easily we can write cos x by sin x. So now here after taking LCM, and if we calculate this result, this sin x goes up. So that's why we have to write this one is sin of x, and this one we get here sin x plus of cos x into dx. So this one is the first step here. What you have to do, we have to break this cot x. I mean cot x to break koibo laibo, break kor pisot jitu result ahibo tak LCM lole etu result ahibo. Is it clear? So now here if we substitute cos x here, then we get sin x. ddx of cos x minus sin x. So minus to bahir lele sin x thakibo. But what happened to this sin x? A sin x to ki hobo? For that reason here again the direct substitution is not possible. So if direct substitution is not possible, then what you have to do here? So we have to arrange this result. So that's why these steps are very important here. If you see the next step to बहुत important hoy. Yet next step to ami ki korim, you have to know this. Eto tomalke mono rakhibo lagibo, multiplying numerator and denominator by 2 here. Kele multiply kori aso olop pisot gam paba. So that's why if you multiply it by 1 by 2, so to balance this result we have to write here, this one is 2 sin x divided by this one we have to write sin x plus of cos x into dx. Is it clear? So here we have to multiply it by 1 by 2 here. This step is very important. We have to remember this. So 1 by 2 integration of, to balance this result here only sin x is there, so 2 to cancel again remains same. So that's why 1 by 2 integration of 2 sin x dx divided by sin x plus cos x. We have to rearrange the result in this way. Now here after this the next step is again another very important step is here. So what you have to write here, or this implies I equals to 1 by 2 is already there here, isn't it? So 1 by 2 is already there, and then here in place of sin x, now you see here integration. This one you have to write sin x plus cos x. So that's why we have to write this one is sin x plus cos of x. Is it clear? So in numerator what you have to write, you see here. So we have to write here, this step is again very important step here. You have to know this sin x plus cos x. First we have to write, is it clear? And then we have to write my plus of sin x minus cos x. Is it visible? Okay. You see here this one dx. So now in this case dx is visible or not? Dx. So that's how we have to write this one is dx. Is it clear? So now let's see here. We rearrange this result again because here 2 sin x is there. So if you see here sin x plus sin x, 2 times of sin x, and this cos x minus cos x cancel, remain same. So these 2 steps are very important here. A duta step बहुत important হয় আৰু এই দুটা step আমি arrange কৰিব পাৰিবই লাগিব. Is it clear? And after that, now if you separate this 1 by 2, integration of. So if we separate here sin x plus cos x divided by sin x plus cos x, so that's why the first step here we have to write this one, sin x plus of cos x divided by sin x plus of cos x. Is it clear? Plus of. If you know, you can directly separate, no need to write like in this way. Tumalka direct cancel koi diba jodi buji poa. And the second step here we have to write this one is sin x minus of cos x, and divided by this one is we have to write here sin x plus cos x, bracket close, into dx. Is it clear? So here you see this sin x plus cos x, we have to divide both the term, sin x plus cos x divided by sin x plus cos x, as well as sin x minus cos x divided by sin x plus cos x. Ami duta part separate koringo. Is it clear? Now here sin x plus cos x divided by sin x plus cos x. What is the answer here? 1, and this one remain same. So ultimately here we get this one is 1 by 2 integration of. So the first part remain here 1, and this one is plus of. Here we get this one is sin x minus of cos x, and divided by this one is sin x plus of cos x, bracket close, into dx. I think all of you understood up to this, isn't it? So now here, after that what you have to do? Now just we have to separate this, and now here I think easily we can apply the substitution method, because first part easily we can integrate. In case of second part, ddx of, if you substitute this denominator part, sin x plus cos x, ddx of sin x minus cos x, or what? ddx of sin x only cos x, and ddx of cos x minus sin x, isn't it? So now here what you have to do, if we take minus common, then easily we get this answer here. Is it clear? So now in this case what you have to do, let's see now. So after this step, now here the next step we have to write after this step. Clear? After this step what you have to write? So this implies I equals to 1 by 2 constant term, big bracket. So if you separate the integration into two parts, so 1 into dx, so that's why we have to write integration of dx, plus second one you have to write this one is sin x minus of cos x divided by this one is sin x plus of cos x into dx. We write this step. We have to just separate the result. I mean, duta part separate coin. Clear? And now here, half of integration dx means this one we have to write half integration dx means x plus of this one you have to write integration of. No need to write integrating constant here, because already one more integration here remains. So that's why after this integration we have to write down the integrating constant. So that's why here we have to write this one is sin of x minus of cos x divided by sin x plus of cos x into dx, and now here bracket close. Now this part we have to integrate. It আমি এই part integrate কৰিব লাগিব. Integrate কৰিব কাৰণে কাক substitute কৰিম? We have to substitute this sin x plus cos x. So that's why you have to write here, let z equals to, if you substitute this one sin x plus cos x. So if we substitute this denominator part, you see here z equals to, we have to substitute sin x plus cos x, isn't it? So we substitute this sin x plus cos x. So that's why, so that what you have to write, so that this one we write this differentiating this one with respect to x. So that's why dz by dx. So dz by dx equal to ddx of sin x cos x and ddx of cos x minus sin x. So if you see this result here, sin x minus cos x required, and here we get cos x minus sin x. So for that reason what you have to do, we have to take minus common from here. Minus ta common loilo. So if you take minus common, then we have to write this one is sin x minus cos x. Is it clear? Or this implies, now if you multiplying both sides by minus and cross multiplying this dx, so that's why we get here minus of dz. So this one we get minus of dz, isn't it? Equals to this one we get here sin x minus of cos x into this one is dx. Sin x minus cos x into dx. Is it clear? So this one we get here. Now after that, I think all of you know how to substitute, so that's why easily we can write this result. Now here, after that, what you have to write? If you see, now the integration part here. So if you see the integration part, so in place of sin x plus cos x, what we can write? A sin x plus cos x we can write z in place of sin x minus cos x dx. So that means you see here, this one. A upor part to zegat sin x minus cos x dx, we can write sin x minus cos x dx, isn't it? In place of this one, what we can write? We can write dz, and in place of denominator part, we can write z, isn't it? So that's why this implies I equals to 1 by 2 is there. So the first integration already we have done, x plus of second part we have to write, this one is the numerator is minus dz and the denominator is z. Is it clear? Or this one we have to write here, half of this one is x minus integration dz by z means log z plus of c, where c is an integrating constant. Is it clear? So this one equals to half of, if we write this one is x minus log z means what? Z means what we consider? Z means this one, you see, z equal to sin x plus cos x. So that's why we have to write this one is sin x plus of cos x bracket close plus of c, where c is an integrating constant. So this one is our required answer. Is it clear? So very simple and easy question. Just you have to know that main two steps are there. If you know these main two steps, then easily we can solve this type of questions. I think all of you understood this one, isn't it? Okay. After 32, now if you see the next question, question number 31, and if you see this question, question number 31, and the 31 is question is given here. The question is given like in this way, sin x divided by 1 plus of cos x whole square, isn't it? So the question is given here, integration, the question is given sin x divided by 1 plus of cos x whole square. So 1 plus of cos x whole square dx, this one is given. Sin x divided by 1 plus of cos x whole square dx, this one is given here. So now here, how can we integrate this question? You see here. So one thing here, very simple here, because ddx of cos x is minus sin x is present there. So here, without arranging this question, easily we can substitute here. So for that reason, first of all, solution here we have to write let I equals to integration. So integration, this one you have to write sin x divided by this one is 1 plus of cos x whole square. So 1 plus of cos x whole square dx you have to write, and then directly we substitute this one. So substitution in such a way that we have to do the maximum substitution we have to do here. So maximum substitution is 1 plus of cos x, so that's why you have to write here z equals to 1 plus of cos x. So if you substitute this part, z equals to 1 plus of cos x. So what you have to do, so that means the meaning is differentiating this one with respect to x. So that's why we have to write here dz by dx equal to ddx of 1, constant term 0, isn't it? So ddx of cos x means minus sin x. So that's why we have to write this one is minus of sin x. And now if we arrange this result, so that's why we have to write here minus dz equals to, we have to write this one is sin x dx. Is it clear? So minus dz equals to sin x dx. I think all of you understood this one now here. So easily we can substitute like in this way. Now if you see the question is given here sin x dx. So in place of sin x dx, you see here, in place of sin x dx, what we can write? We can write minus dz, and in place of 1 plus cos x means what? Z. So that means in place of 1 plus cos x, what we can write? Z. Z means z square, here we write. So ultimately here I equals to what we get? Therefore I equals to integration. In numerator we get sin x dx means minus dz, so that's why we write here minus of dz, and in denominator 1 plus of cos x means what we write? Z. So that's why we have to write this one is z square. Is it clear? So z square. So now this one is minus of integration z to the power minus 2 dz we can write. Z square, that means z to the power minus 2 dz easily we can write. So it is of the form integration x to the power n dx, isn't it? So integration x to the power n dx means what? X to the power n plus 1 divided by n plus 1. So this formula we have to use here. So if you apply this formula here, minus of, then what we get here? Z to the power minus 2 plus of 1 minus 2 plus of 1. and plus of c, where c is an integrating constant. So here minus 2 plus 1, that means minus 1. So this minus minus ultimately plus. So what will remain here? Simply z inverse. So that means here simply remain z inverse of plus of c. That means z to the power minus 1 plus of c here ultimately remain. So z means what? At starting already we consider z means 1 plus cos x. So z inverse means 1 by z, we can write 1 by z, and z means what? 1 plus cos x. So that's why simply we have to write this one is 1 by 1 plus of cos x. 1 by 1 plus of cos x plus of c. Which one is our required answer? I think all of you understood this one now here, isn't it? So in this way, each and every question from the exercise 7.2 you can solve. Is it clear? Solutions are already given, so you have to try yourself. And in our next class, we have to proceed to the next part. Next part is what? Some trigonometric identities. With the help of some trigonometric identities, we have to solve some questions and we have to apply some formulas there also. Is it clear? I think all of you understood this one. It's okay? Okay, thank you.